Okay, here we have 6.7. We're using word problems and we're using two right angles to solve two right angle triangles to solve a question. Okay, I have the diagram below. Okay, and it says find h. Now h is going to be based on, we have a lot of missing information, but there's a lot of information that we do have. We have these angles here, and we have the adjacent side of it. And we're never asked for the hypotenuse of it, but we could find it out if we wanted to. We could find the hypotenuse of this and that. And we could also find this length and this length, the opposite sides of my angles. And of course, we could use that to find h. Okay, so what's the best plan of attack? Is to find these values right here, the opposite sides, and then subtract them to find my h value. So for triangle ABC, that's the bigger one, by the way. Let's clear markings. That's ABC. What's my angle? My angle is 36 degrees. What's my adjacent? It's 30. And my opposite is BC. So we go along and solve it. BC equals 30 times tan of 36. We plug that into our calculator. We get that BC is equal to 21.8. 21.8 for the whole thing. For my triangle, ADB, that's a small one. A to D to B. We have our angles, 25. Our adjacent side is 30, and we want our opposite side. We use the same ratio. Tan of 25 degrees equals dB over 30. Multiply both sides by 30. We end up with dB equals 30 times 25. We plug that into our calculator, we get dB is equal to 14. So we have the whole thing is 21.8. We have this is 14. What are we left with? We're left with h equals 21.8, the big one minus the small one. That's just equal to 7.8. And that's example 1. Okay, given this diagram, find h. Now let's talk about what we know. We know these are our angles. We know the opposite side of this angle. But what we don't know is the opposite side of this thing. And we don't know any hypotenuse. So what can we find out? That's the question that you start to ask yourself, is what can I find out? And I know that I can find out this hypotenuse right here. I can find this out. Or I could find this out. Now, after a little bit of practice, the hypotenuse isn't going to give me anything. This h belongs to the bigger triangle. And so does this line right here, this adjacent side. So in order to find h, I need some information about the larger triangle. And this adjacent side, if I can find it, and I can, will give me that information. So that would be my first step to find. For angle BCD, well, that's BCD. I know that tan of 25, because I will have opposite, and I want my adjacent, so I'm going to use that angle. So I'm going to use that ratio. And the angle here is 25 degrees. So tan of 25 equals 100 opposite over adjacent. Multiply both sides by BC. Well, cross that out. And then divide by tan of 25, which is just a number. Multiply by 1 over tan of 25, which is the same thing as dividing. And that's how we end up getting that. BC is equal to 100 over 10 of 25. And when we plug that into our calculator, we get the full length is 214.45. From here to here is 214. Now let's look at our big triangle. We have ADB. Ooh, that's written wrong. It should be ACB. ACB. What do we want? We want the hypotenuse. What do we have? We have, well, relative to this angle, we have adjacent. So how are we going to find that? Is there let's look at it. We haven't had to do this in a while. So can we use a sine law? Do we have opposite? No. We want the hypotenuse. Can't use that. Can we use the cosine? Well, we have the adjacent. We want the hypotenuse. That's what we're going to end up using. Let's just make sure it's not tan. Well, you need the opposite and adjacent for that. We only have the adjacent. We can find the opposite, but we don't really want to. So we're going to use, keep for now. So our next step is to use cos of 45, that's our angle, equals adjacent over hypotenuse. AC is hypotenuse. And when we rearrange basically we cross multiply. This is multiple step. This is 2 steps. If you want to see it, it's basically the following. It's cross multiply AC times cos of 45 degrees equals 214.45, and then just divide by cos of 45. We end up with what we see here. Plug that into your calculator. You end up getting AC equals 303, and H is equal to 303. And we solved H. A TV relay tower is supported by 2 guy wires, just wires for now, both anchored in the ground 22 meters from the base of the tower. So I have my tower. I have both of them angled to the ground 22 meters from the base of the tower. The first wire is attached to the tower, basically from here to here is 22 meters. The first wire is attached to the top to the tower 15 meters above the ground. This is 22 meters. That's 15 meters from here to here. And while the second wire is attached to the top of the tower, if the angle between the 2 wires is 24 degrees, what is the height? So that there is 24. We don't know what this angle is. So the first step is, we have 2 sides. Find out my angle. Now we have, relative to this angle here, theta, we have our adjacent and we have our opposites. So we use tan of theta equals opposite over adjacent. And to find our angle, we use the inverse tan function. We plug that into our calculator, we get theta equals 34. Which makes this entire thing 58. Because 24 plus 34 is 58. Now, we can find this full height, this is our opposite side, by using our angle of 58. And the fact that our adjacent side is 22. So tan of 58 degrees equals h over 22. And we solve for h, we end up getting 35.2. Next word problem. It's about a ski lift. And we know that at the bottom of the ski lift there are 2 vertical poles. One is 15 meters tall. The other one is 10 meters tall. The ground between the poles is level, and the bases of the poles are 8 meters apart. So that's 8 meters apart. One's 10, one's 15, one's 8 meters. The poles are connected by 2 straight wires. Okay, 2 straight wires. Each wire runs from the top of one pole to the bottom of the other. What angle does each wire make with the ground? So I want to know that. So we know opposite, and we know opposite and adjacent. So tan of theta, we use inverse tan for that. And when we plug it into our calculator, we get the angle is 51.34. So one of them is going to be equal to 51.34. Now let's get the other angle. So once again, we have opposite, we have adjacent, and we use our inverse tan formula for that specific ratio of 15/8. We get that to angle 61.92. Part B, how high above the ground do the wires intersect? To the nearest tenth of a meter. So I'm looking for that. Now, and that. That's H. I'm looking for that height. Now, I know that the full thing is 8, but I don't know what each individual wire is. But I do know the angle. I know that's 62, I know that's 51, and I know that's going to be, let that be L. And that's 8 minus L. So let's look at the yellow triangle. Tan of 62 degrees equals H over L. That's my yellow triangle. The green triangle, tan of 51 equals H over 8 minus L. Now, don't let the tans confuse you. This is just a number. It's just a decimal number. It's a ratio. But I have 2 equations and 2 variables. So let's solve. Tan of 62 is 1.88. Tan of 51 is 1.235. L equals H over, we rearrange this. We multiply both sides by L. We multiply both sides by L. And I don't know why I wrote L in terms of H. I could have just kept it as, whoops, why did I cross out that L? We multiply both sides by L. And then divide by 1.88 to isolate, we end up getting this. That's 1 and 2. So substitute L, 1 into 2, and we end up getting 1.235 equals H minus 8 minus. We see an L, we substitute this L into this L, we get H over 1.88. All right, let's do this math. What did we do first? We multiply the denominator. We multiply both sides by 8 minus H over 1.88. So we can do that. And we basically did it to move, and we multiply this side by H over, 8 minus H over 1.88. Cross this out. And that's why we're left with H on one side and that on the other. Multiply both. Distribute this 1.235 to both. It's just a little bit of complicated math here. And 1.235 is equal to 9.88. 1.235 divided by 1.88, that's where I got my 0.66H. Move that to the other side, we end up getting 1 point. That becomes a plus, 1.66 h. And then we do the division, and our height is 5.95. And that's basically our answer. Therefore, the wires intersect. Therefore, the wires intersect 5.95 meters above the ground. And that's it.